Now we're going to look at a 30, 60, 90 degree right triangle. And in order to understand the relationship between the legs and the hypotenuse in this right triangle, we need to start an initial relationship. We don't have a congruency like you do in 45, 45, 90, but there is a relationship that we can find. So if you were to um, focus on this 30-degree right triangle and the leg opposite the 30-degree right triangle, which I'm going to call X, and the hypotenuse. So here's the hypotenuse. Um, and so the leg opposite, I'll call it X, and the hypotenuse is here. So if I use a calculator, I can figure out what the sine of 30 degrees is. So I'm going to go ahead and use the Desmos calculator, remembering that it needs to be in degree mode. And I'm going to type in the sine of 30. The sine of 30 is 0.5. Okay, so if the sine of 30 is equal to 0.5, well, 0.5 as a fraction is equal to 1/2. And so I can use this 1 to 2 relationship to say, oh, if I'm calling the short leg here X, then the hypotenuse that I don't know, well, that must be equal to 2X. And that's because of this idea that a sine of an angle is the opposite divided by the hypotenuse. So if the opposite is 1, the hypotenuse is 2. If the opposite is X, then the hypotenuse is 2X. And so there I've established a little bit of a relationship. And now I want to find this missing side. And so I can use the Pythagorean theorem again. So the Pythagorean theorem tells me I can find that side using x squared plus the unknown side that I'm solving for, b squared, is equal to the hypotenuse squared. So 2x squared is actually equal to 2 times 2 is 4, and then x squared. So I can solve for b squared by subtracting the x squared from both sides. And so I get b squared. 4x squared minus x squared is 3x squared. And now we can take this one step further by square rooting both sides of the equation to get b by itself. B again is what we're trying to solve for. And the square root of 3x squared, well, that's equal to the square root of 3 times the square root of x squared. The square root of 3 can't be simplified, but the square root of x squared is equal to x. And so b itself is equal to x root 3. So in a 30, 60, 90 degree right triangle, the short leg, the long leg, and the hypotenuse all have this relationship. So the short leg is x. That means then this long leg would be x root 3, and that's the leg opposite the 60 degree angle. And then the hypotenuse opposite the right angle is equal to 2x. So that will help us with problems such as this. So find the unknown parts of the triangle. Triangle ABC is equilateral. So I'm going to draw a little diagram here, assuming this is a 30, 60, 90 degree right triangle. The short leg is x, the long leg is x root 3, and the hypotenuse is 2x. Okay, so we can take this apart. So the unknown sides that we're looking for are x and y. And if we take this apart, knowing that it's an equilateral triangle, that tells me these are going to both be 60 degrees. And these smaller triangles here, assuming this is a right angle, will each be 30 degrees. I know these triangle ABC is an equilateral triangle. An equilateral triangle is also equiangular. So since the angles in a triangle add up to 180, each of the larger angles is 180 divided by 3, or 60 degrees. And then angle A was split into two smaller angles, and assuming that they're congruent, if this is in fact a right angle down here, then 60 degrees divided by 2 tells me that each of those smaller angles is equal to 30 degrees. So now for the work to figure out the sides x and y. I'm going to take this right side of the triangle and just make my own diagram and fill in what I know. 60 degrees, 4 root 3, and 30 degrees. And so here we go, looking at the relationship between the long leg, the short leg, and the hypotenuse. So if this long leg is equal to 4 root 3, then I know right away that this is equal to 4. And so looking at x root 3, the short leg is x. If the long leg is 4 root 3, the short leg is 4. And that means the hypotenuse is going to be 2 times that short leg. So 2 times 4 equals 8. So I've found the missing sides. X is equal to 8 and y is equal to 4. Now, I'm going to look at one more example here. And in this example, I'm going to make a right triangle and have that right triangle get stretched up here. And, oops. There we go. Okay, so I'm going to say this is another example of a 30, 60, 90 degree right triangle. And I'm going to say this time that instead of, kind of an easy value for that long leg, I'm going to have a more difficult value to work with. And so I'm going to say this time that this long leg is actually going to be equal to 11. It has a length of 11. And assuming that this is a right angle, this is 60 degrees, and this is 30 degrees, I want to know this side, the short leg, and the hypotenuse. So I'm going to call this side A and this side C. So to find those two sides, again, we need to think about the relationship that we established already in a 30, 60, 90 degree triangle. If this is x, this is 2 times x, and this is x times the square root of 3. So coming back to this diagram, if I know that whatever A is, that this side 11 is equal to that value times the square root of 3, then I can set up an equation that says 11, the long leg, is equal to a root 3. And that's just using the relationship from over here that we found between these two sides. And so to solve for a, to get a by itself, I have to divide by the square root of 3. So a is equal to 11 divided by the square root of 3. And similar to the last problem in the 45, 45, 90 degree right triangles, we now have this in a form that isn't standard, and so we have to rationalize the denominator. The square root of 3 is irrational, and it can't be simplified, and so we're going to go ahead and multiply the square root of 3 to the numerator and the denominator, essentially just multiplying the fraction by 1, so we haven't changed its value. So what we have is 11 times the square root of 3 over the square root of 9. And since the square root of 9 is equal to 3, then a is equal to 11 times the square root of 3 divided by 3. So this side is 11 root 3 over 3. And then the last step, to find the length of the hypotenuse C here, we just have to take the answer for side A and multiply it by 2. And when you multiply a fraction by a whole number, you simply put a 1 under the whole number and then multiply straight across. So 11 root 3 times 2 is equal to 22 root 3. And 3 times 1 is equal to 3. So side C is equal to 22 root 3 over 3. And that concludes our review of special right triangles.